Welcome back to InPOD, your home for all things inflow. I'm your host, Nit Sweeney, and I mentioned last week that I was going to get an episode together with Joe Formicola to talk about CAELYNX, and that was either going to be this week or next week. Well, it is this week. So this week, Joe joined me on the podcast, and we talked about all sorts of stuff, simulation, and specifically CAELYNX, because, I haven't really talked about it much on the podcast, and you might not be aware of, who is CAELYNX, what are they, how do they get founded, what's their story? So I asked Joe some of those great questions. I asked him, what inspired him to get into simulation? What are some of his favorite studies that he's ever done? And he's going to share a really fun story about one that he did for a car manufacturer. So I'm not going to spend too much time introducing this. So I hope you guys enjoy my interview with Joe Formicola, founder of CAELYNX and now the VP of CAE Solutions with CATI. So this week, I wanted to get into the topic of CAELYNX. I mentioned it last week that it was going to be coming up, but I wanted to get to this sooner rather than later. So what I've done this week is I've brought in Joe Formicola, the former, the founder of CAELYNX and the current VP of CAE Simulation inside of CATI Inflow. So Joe, welcome to InPOD. Welcome to the podcast.
Okay. Yeah. Thanks for having me.
Absolutely. I'm really excited to have you on because CAELYNX, we acquired CAELYNX back in, I think, Q4 of 2020, something like that. And ever since then, I've been really interested in CAELYNX as a brand, as a story, what you guys do, because it's kind of different than what I've always experienced. So I've been around the solver simulation game for a couple of years, but even that's really different than how CAELYNX operates. So I guess to start off the conversation, Joe, you founded CAELYNX. When did you first found CAELYNX and kind of what was the inspiration behind that?
Well, started CAELYNX in 2005, and I've been in CAE consulting almost my entire career. I did a couple years at Chrysler's manufacturing facility and building prototypes and working on the shop floor and problem solving, all kinds of different things. But then I went into CAE and came to Ann Arbor, a small company that was basically a spinoff out of University of Michigan, and just really fell in love with simulation and finite element analysis. And I realized that that's kind of the career that I wanted to move forward with. So I've been in CAE for, it's got to be, unfortunately, probably 35 years now.
Unfortunately.
And, yeah, time flies. But at some point in the process, I decided that, I was a little bit entrepreneurial, and being in consulting, you're always involved in sales and marketing and project work and everything. And I decided it would probably be a good idea to just see what I could do on my own. Yeah, so that was kind of the motivation, and it took off. It took some time, and started doing projects and working long hours and doing the best that I could, and then started bringing people on. Eventually became a distributor for the Simulia products from Dassault, and was able to not only do consulting projects, but also sell the software, do training, do support, and all that kind of stuff. So that really added another element to CAELYNX that allowed us to grow. And that was, I think, in 2011 when we did that.
And it's a labor of love for you too. Like you wouldn't get into this if you didn't want to do it, but working those long hours and getting into doing this and becoming a reseller of Simulia and the Dassault products, it was a labor of love for you as well. But out of all of that, and this probably says a lot about me. The thing that I took away was Ann Arbor, University of Michigan. Oh, I'm not a fan. We don't have our cameras on, but I've got an Ohio State blanket sitting right behind me. I'm wearing my Ohio State t-shirt. I'm a diehard Buckeye. So I guess we'll have to find a way to get through this conversation without talking football or something like that. But
yeah, I'm sorry about that for you.
No, it's always fun to find those commonalities. But what I find fascinating is that Simulia, that's a really big thing to take on. Like I love knowing that you started at Chrysler, because that's such a it's such a tangible thing. Like people think, oh yeah, well with the cars, like you can see on TV commercials, like the crash test stuff, and that's a little bit extreme for what simulation's for. But what were those kind of things that you loved about simulation that were like, yes, this is what drew me to it in the first place? Because I love physics. I think physics is a fascinating prospect. Was it kind of you love the physics of it and you wanted to see how things reacted? Was that kind of what drew you into doing simulation and CAE in particular?
Well, yeah, I think you're right. I mean, it was I was really kind of on a little bit of an academic track. I was very interested in the math behind mechanical engineering and the programming, and then I went and worked at Chrysler in the manufacturing facility, and I kind of felt like I was losing some of that. And so going back into CAE made me feel almost like I was going back into an academic environment, because at that time, things were not as developed as they are now. Now the tools are just phenomenal, but before we were piecing subroutines together. We were trying to figure out things that it kind of felt like nobody really understood what was going on with people's parts and components before, and we were at the beginning stages of really being able to hone in and help people understand the behavior of their products, and that was great.
And I think that kind of leads into another topic I wanted to go through, because you've been doing this at CAELYNX started in 2005, so that's 16 years now. And so you've seen how everything's kind of evolved. Like I think 2005 might have still been Cosmos Works inside of SolidWorks. So you've got to see how everything has kind of changed. So one of the things that I wanted to ask you about is we've seen this drive, especially in the last year, to cloud-based systems. And I know that in the simulation world, that's always been a little bit of I don't know that these cloud machines can really handle everything we want it to. But Joe, can you kind of talk to me about what you've seen changing just in the last 5 or 10 years, especially with this push in the cloud? Have we seen a bigger push to that, or are we seeing it to be, people are still apprehensive about it? Where do you kind of see that going versus where we've been kind of going the last 5 years?
Well, I think the apprehension is going away because the cloud is here and now, and it works. So if you're a real hardware person, you want to have your own hardware and tinker around with it. But if you're someone who just wants to do CAE and predict the behavior of mechanical systems, then you want as much power as you can get. Mm-hmm. And the cloud allows that to happen for you, because you can have the ability to have so many CPUs available to you whenever you want, accessible. It just rounds out your tool set so much to be able to have that type of capacity at your fingertips.
And having that capacity means that we can run all kinds of different studies. And one of the things that I know we kind of talked about a couple of weeks ago when we first mentioned doing this episode is like there's so many different ways we could go with talking about what CAELYNX does, because there's electromagnetic simulation, there's the statics, and then there's a whole bunch of other ones that I've got written down somewhere that I definitely want to talk about at some point. Probably not in this episode. We'll use this more of an introduction. But as CAELYNX, like what are we able to do? Again, I keep saying CAELYNX, even though CAELYNX is, I guess, part of CATI. So really just as CATI, what kinds of things are out there that we can do for customers? Because obviously CAELYNX is a service-based team. That's the whole goal of it, is that we can make the lives of our customers easier by doing things for them. What kinds of things can we do for these different people that are looking for simulation services? Is it like you must give us this one thing and we can only do this one simulation? Can we do this broad reach of simulation? What can we do as a team to make life easier for those that want simulation services?
Well, one of the first things is that on the services side, we're really a team of problem solvers. So we're going to figure out what's wrong, what's right, how to improve their products, and that's really where a lot of the fun exists. The other area where a lot of the fun exists is bringing that technology to the customer and having them build that team up in their own company. So being able to do the technology transfer, build these methodologies, transfer it over to them, train them on the software, support them through the whole process of implementation. We can do it from the very beginning all the way through to the end. We have customers where we're mainly doing services, but we're doing services as part of their CAE team. They may have 30 CAE engineers.
Wow.
But they have peaks and valleys.
Mm-hmm.
And so we can be, we're basically an extension of their team. And they understand that we have similar capabilities to them. We may have some strengths. They have some weaknesses. They fit us in the right spots. And then we have other customers who just are taking a look at building this capability in-house, and they want to figure out the best way to do it. And those types of companies we're very well suited to help them out as well. So there's a large spectrum, and it's all of it's exciting. We're happy to get involved in all of that.
Listening to you talk about how much your passion as a problem solver and what you guys like to do, I can see why Rich and Rob are so excited to bring you guys on board and have you join our team, because I think that fits really well into what we've done as CATI and Inflow, is that, we're a group that we try to figure out how can we best help different people and what they need. And one of the things that I love about the different services, especially with what CAELYNX does, is it's easy to get started. Like you present the problem to us and we can help you figure out whatever that solution is. Now, you did mention you were talking about that problem solving, and one thing I wanted to ask, I'll put you on the spot here. Do you have like a favorite problem that you've ever been presented, even just a little bit conceptually, because obviously we don't want to talk too much about individual customers, but Joe, is there like a favorite? I really loved it. Like this was kind of what the customer was dealing with and what we found using different studies. Do you have any good stories like that you can share?
Oh yeah, there's a lot of them for sure. I'm trying to think of something right now. It's the projects that we're doing right now are kind of the ones that are most on the tip of the tongue, but I'm not sure how much we should really be talking about those. I would say one that I did that was at the beginning of CAELYNX that was pretty important to me and the company and our customer General Motors was the development of a vibration model for electric motors. Because hybrid vehicles were just coming out, we were putting these electric motors into transmissions, and they were noisy, and it was just very difficult to understand why. And so I helped them develop a methodology to do acoustic analysis, which was heavily involved in the structural vibrations of those of the motor and how it tied into the housing of the transmission. And that was probably 1.5 years in the making, that project. And it turned into just a standard procedure over there. So it was, really cool. I'd say that was a very exciting one for sure.
A lot of physical testing, being involved in the middle of it too, and validation, which was really great.
What I love about that is that as someone that would just be a consumer of such a thing, it's one of those things where I wouldn't even know about all of that ever happening, because it was one of those things that it solved a problem that the consumer never even had to know existed. The motors are noisy. How can we make that quieter? And all you hear with like electric cars and that is like whenever I have a Tesla drive by me, it's like, wow, I didn't even hear it until it was by me. And then I realized, oh, that's what I was listening to. So that's really cool, is that it solves a problem that the consumer never even has to know existed.
Hopefully they don't know it exists.
Hopefully they don't know it exists. That's definitely true. But 1.5 years in the making, like that's an extensive study. And that is one of those things that I do see a lot of people, I guess what we've seen happen, like simulation, people still complain like, oh, it's not the fastest thing in the world to run like a solid sim study. I would argue, okay, then do all the math by hand. And then they quickly realize, okay, this is actually very quick. But it's still one of those, I guess, bottlenecks, is people say like, this is really, really slow. So one of the things, I just kind of back into that cloud realm, but then some of the stuff that we solve as problems is that we can save a lot of headache because we've got access to some pretty beefy computers that can run these simulations. Like you don't have to run this on your local laptop, right?
Yeah, that's right. Yeah, you can. I mean, there's even laptops are pretty hefty nowadays. But when you get into stuff that's really computationally intensive, which we do a lot, then yeah, you just you ship that to the cloud and run on 256 CPUs and get your answer in a couple hours. Whereas otherwise, you'd be waiting around for a week.
Oh, that's really cool, though. Going from hours to week, like I'm passionate about automation and any way we can save time, and being able to decrease wait times by that much is pretty insane. But you talked about going to the cloud there, and I guess that takes me into one of the last big things that I wanted to hit on for this discussion, and that is simulation has grown to be very accessible. Like it didn't used to be. 20 years ago, it was hard to get yourself a simulation package. Like maybe GM and Ford and Chrysler and Chevy have them, but really like the average consumer couldn't get it. Versus a couple years ago, I built a shelf that I wanted to mount on the wall and I ran a simulation study on it on just my laptop. It took me a couple minutes, but I was able to do something like that. So the accessibility of simulation is growing, and it's only going to keep growing with the integration of the 3D experience platform. So, one of the things that I like about this, and I want to get your thoughts on, is our tools aren't siloed anymore. So having everything on the 3D experience platform, what is that doing for simulation from the consumer perspective, but as well as from the CAELYNX perspective? How nice is it that everything's going to be integrated to the 3D experience platform, and with that being such a key focus of Dassault going forward?
Well, I think it's going to be great for the consumer, especially the SolidWorks users, to have access to all the Simulia products, whereas before there was a limited scope of CAE capabilities in SolidWorks. Now you're going to have access to basically everything and anything. So you're going to be able to do nonlinear crash type simulations, impacts and drop tests, and really high-end fluid dynamics projects, all that kind of stuff. So from the consumer's perspective, it's a game changer, just like the cloud is a game changer, and it's going to just blow everybody's mind, I think. I'm not sure how long it's going to take for everyone to adapt to it, but it's coming, and it's not going away. From CAELYNX's perspective, it's really good because it gives integration with the CAD system, and it gives us something that we can focus on. There was, with so many standalone products out there in the Simulia domain, we have electromagnetics, we have fluids. Now on the platform, everything's going to be integrated together. We're going to be able to couple all these physics together, so that when we do an electronics cooling, we can do the electromagnetic simulation, figure out the heat dissipation from that, put in the forced convection from a fan, and then port all those temperatures over to a structural model, figure out the thermal fatigue and the thermal expansion and all that kind of stuff. And it just really improves the tool set to have everything on the same platform and connected. I guess that's kind of what I'm going to say about that.
It opens the door to so many possibilities. Like you're talking about what we can do, and it's like we take this product from you design it in SolidWorks to now you test it in a very sterile environment, and now you start adding in these other factors. Like we can test everything from start to finish. I love that about simulation, is that this is not going to be in theory, it's going to act like this. Like, no, we can be fairly confident. Like these simulations, they're very accurate from everything I've seen. Do you have like a factor of safety on that? Is that a really big thing there? I guess the accuracy standpoint, I know a lot of people ask about that. I know that it's very accurate, but do you have like a number on that, Joe?
No, I don't, because it depends. It definitely depends. One, if you have someone, who's been using CAE for a long time and has a lot of experience in different industries, you can be pretty sure that you're going to be pretty close and you're going to be getting the right solutions. But then if a company has been developing their techniques, over 6 months to a year or something like that, they've got to a point where they've been able to develop confidence in the simulation tools. those companies, they're just reducing their number of physical prototypes like crazy. And the engineers are no longer saying, well, oh, how long is it going to take to build a prototype and so that we can test it again? They're saying, what does the FEA say? What does the FEA say? Can we get an answer by tomorrow? And yeah, lo and behold, you're not only going to get one answer, you're going to get a full design of experiments. You're going to understand multiple parameters, and you're really going to just advance your product development skills and get things done quicker and understand your product better, understand the behavior.
I remember my dad used to tell me that one of his very first jobs was working at a fan company. And I swear, he might have been joking with this, but he said like one of his jobs was to make sure the fans were sound. And like he jumped on them, and that's how he tested them. And then if they broke, well, they weren't very good. And it's so cool to see the evolution of technology that we go from my dad used to jump on fans in his 20s for a job to now we can use SolidWorks simulation or Simulia or Abacus or a whole bunch of different solutions that are out there to make it so that we can pretend like there's a man jumping on top of our stuff to see exactly how it's going to react. It's really cool to see the evolution.
Engineers love to break stuff. I mean, that's what they want to do. That's what they want to do. So simulation, you can just break a lot more stuff.
You can break a lot more stuff without actually having to rebuild it.
Yeah, that's right. Yeah.
All right, Joe. Well, thank you so much for joining me on this episode. I really enjoyed it. I hopefully can get you back on here at some point. We can actually go through more in depth on the simulation because we only just scratched the surface here, but I'm really excited to have you guys on board and to be able to work with you guys more because this is going to be fun.
Okay, well, I really appreciate the time, and I'm glad we did this today.
Definitely, me too. All right.
Thanks, Nick.
All right.
See you later.
Thank you, InPOD listeners, for joining us. That was Joe Formicola, the former just founder of CAELYNX and our VP of CAE services at CATI. Thank you guys so much for joining me. I hope you enjoyed that conversation. We'll be back next week with another episode. But until then, have a great weekend, and I'll talk to you guys next week. See ya.